So what we're going to do is make a proportion here. We're going to cross multiply. 25,000 times 80 million is going to equal 5 million times whatever this is. So we're going to make that into a proportion. 25,000 over X equals 5 million over 80 million. So cross multiply across that diagonal, and then divide. I know that purple is hard to read, but if you cross multiply in your calculator, 25,000 with 3 zeros times 80 million with 7 zeros. That is a lot of zeros, right? 1, 2, 3. And then divided by 5 million with 6 zeros. 1, 2, 3, 4, 5, 6. What number goes in this box right here? A 4 with how many zeros? $400,000. 400,000. That's exactly what I got. Yep. So then what math would we do to find the homes powered? We're going to take away that 80 million and put in the 660,000. 66000. Right? So now we're going to cross multiply here. 25,000 times 666, or 660 divided by 5 million. How many homes can be powered currently? 25,000. How many homes can be powered currently if we cross multiply?
3,300.
I think that is correct. Right? So we're going to go from 3,000 homes being powered today to almost 750,000 homes being powered in 5 years' time by wind energy. That's pretty cool, right? I think that's pretty cool. Save the planet one tree at a time. So what would I replace the 660,000 with in order to find the watts generated? 25,000 times 8.8 million.
Yeah.
And then divided by 5.5 or 5 million. And how many watts are generated? So all I'm doing is using what I know about proportions. Been using proportions for a long time in real life. I do 25,000 times 8 million and then divided by 5 million. And what do I get? Got 44 something. 44 million or 44,000?
44,000.
44,000, absolutely. Okay. What do you guys think about having giant windmills 27 miles off the coast to the beachfront? Do you think that's a good idea or a bad idea?
It would limit the types of ships coming in, but overall, it's kind of good.
So I think Riley makes a fair point. We saw one of the tankers go past, right? Or one of those cargo ships that's always going in and out of the channel at the Chesapeake, where the Chesapeake and the Atlantic meet. And it could impact that kind of travel. What are some other factors they have to think about?
Oh yeah, the naval base will become in operation.
Why would that be?
Because they have such
So I think they should still be able to get past. If you look, the footprint of this is pretty small. Once they build it, it's a pretty small footprint, and it's so big the blades don't even come down within like the top of the water. So there's a lot of room. It might cause them to have different paths, right? And it might be problematic while they're building it because they need these platforms out here while they build it. That's for sure. You guys are coming up with a lot of good thoughts. What else?
Weather, like, what if,
Yeah, what happens in a hurricane? Like, would it break in a hurricane?
well, I'm pretty sure
There are for sure safety features. Does it have very much of a profile? So I don't know if you guys have ever driven in a storm. You guys are kind of just getting your driver's licenses. When I drive my little like Hyundai Accent, it doesn't have a very big profile. So it doesn't like, the wind doesn't blow it around very much. But I used to drive when my kids were little, a big Expedition. And that thing, when I drove it over bridges and it was super windy out, because there was so much surface area on the side of the truck, the wind would try to push that car around like crazy. Is there very much surface area on this windmill, or is it pretty slim and sleek?
it's pretty fun.
It's pretty slim. So it's not going to have a whole lot of surface area to bother it. What they do, my understanding, when there's big windstorms, is they let it freely spin, but it's not generating electricity. So it can freely spin so that it's not, so that it doesn't break, but it doesn't have the resistance that's caused while it's actually generating electricity. So in big storms, these are spinning, but they're not producing electricity. Anybody have an idea of how they get the energy from here into shore 26 miles inland or 27 miles inland? What do they have to run underwater?
Huge,
Yeah, a giant cable.
and you became a robot.
Oh, did I? Darn it. I hate it when I robot voice. Hopefully it'll come back soon. So let's come down here. Hopefully everybody has that chart filled in. I want to calculate, let's say like my junior offshore wind, and then efforts to increase sustainability within the region's energy grid. So let's see what I have in mind. See if it's the same thing. So let's take a second, read through this link, see if we can pull up any more information. So anytime you find a good piece of information, put it in the chat. Any new information here?
Can't hear that well, so that's probably why we're not responding.
Any new information?
Now you're back.
Oh, good. Any new information on this slide, on this website?
1,100 jobs will be made once it's fully built.
Yeah, absolutely. Do you think those are tech jobs? Do you think people are going to need degrees for those jobs?
Yes, definitely.
Yeah, probably. So kind of cool, right? I think it's kind of cool anyway. All right. In an effort to do all of that, now what I'd like to do is try, ooh, hello. How big are these wind turbines going to be, right? So use the images above to complete the table below. Estimate the diameter of each of the turbines as half of its height. Okay, it's not going to be perfect, but it's going to be a reasonable estimate. So how tall is this little baby home windmill? About, would you say? 100 feet is going to take right to the middle. Do you think it's a little bit taller than 100 feet?
Yeah, it would be like around like 120.
Okay. So if it's 120 tall and the diameter is half of that, the diameter would be 60. So if the height is 120 and the diameter is 60, what's the radius? Radius is half of the diameter. So it's going to be 30. So we're going to put 30 in here. Oops. What about the business farm? How tall do you think that one is?
It's
150.
150. So if we make this into a 150, then the diameter would be what? Mm-hmm. And the radius would be what?
37.
Mm-hmm. What about the wind farm? So when you drive south, like towards North Carolina, you see a whole bunch of wind farms. This is how big those are.
around 380.
380. Okay, I like that estimate. So if the height's 380, what's the diameter?
190.
And then the radius would be?
91.
Caitlin, you're on fire today. 95. And then we've got a Statue of Liberty, right? So that kind of gives you a benchmark. If you've ever been up to New York, those wind farms down towards North Carolina are bigger than the Statue of Liberty. What about this offshore wind turbine that we're talking about? How tall is that?
660.
660. Oops.
Also, see the other one? I see that it says 360 feet, like right above it.
I do. So our estimate was a little bit too tall. Do we want to modify that?
What is that? Or
Probably not. So if it's 360, then it's 180 and it's 90. So I'll scroll back down and we'll see if that matters. What about the 660? If the total height is 660 and the diameter is half of that, then the diameter would be 330 and the radius would be 160. Oh, thanks, Sammy. Yeah.
It's only 5 big difference.
Yeah.
Yeah.
So let's come down here and see. Oh, yeah. So we can either change that to 90 or keep it at 95. That's why our estimate was really spot on. So it doesn't matter. 90 to 95. And then offshore coastal, Sammy calculated for us is 165. That's huge. How many times more is the offshore than the home? So how many times bigger is the offshore than the home? What math would I do for that? Where do I put my calculator? How many times bigger?
That would be 5 times bigger.
So
Yeah, a little bigger than 5 times.
165 divided by 30 equals 5.5. Is that what it equals?
That's what I believe it is.
165 divided by 30. I love it. 5.5, right? So how do we calculate the circumference? Like the distance all the way around? What's the formula for circumference? 2 times pi times the radius? So calculate those for me. Calculate what the circumference difference is, or for the circumferences for all of those. And when you have one, put it in the chat or unmute yourself. Let me know what it is. My chat evaporated again. It makes me crazy. Oh, there it is. It's just hiding. So if we get our... Go ahead, Daniel.
Are we figuring out circumference for each of them?
Yep. Figure out circumference from each of those. And you can either use the 90 or the 95 for the wind farm.
Thank you.
Mm-hmm. And as soon as you have it, put it in the chat and I'll add it to the table. Nice, Brianna. 188 for sure. And that's feet. So everybody should be calculating circumference. And putting it into your table. Second one, I 100% agree, William, is 235.5. Daniel and William got my range. So 565.2 to 596.6. Because we had two radii, we're going to have two circumferences down here, and they're going to be a little bit different. So what about the big one? Wow, Justin. 1,036.7. And all of those are feet, right? So how many times bigger is the circumference of the offshore windmill versus the home windmill? We're going to take those and do our division. So 1036.7 divided by 188 gives us what? Do we get 5.5 again? kind of an interesting relationship.
For the offshore, I got the same thing, but this one was like 2.
And that's because you probably use the pi button, or Justin used the pi button and you used 3.14. So when we estimate with pi, you definitely have kind of different answers sometimes. Okay. What about the area? How do I find the area? What's the formula for area? Pi times r squared. So let's calculate the area. Pi times r squared. I love that I'm getting different answers from everybody. So you can skip ahead. You don't have to do the first one. Calculate the area for one of those windmills. Brianna, you are 100% right. The first one is 2,826, and that is feet squared, right? So area is square feet. Anybody got the second, the third, or the fourth? Nice, William. The second one is 4,415. And that's also feet squared. And they grow really fast here. And I put 25, it should be 15. And we can put the 0.6 to make it more precise. So I'm looking for the area of the blades for those windmills out in Chesapeake and the area of the blades for our giant proposed windmill off the shore of Virginia Beach. Caitlin, yeah. 2,833.8 feet squared. So 28,000 square feet of surface area out there in Chesapeake. And I think that was the bigger one, right? That was using 95. I got 20. Yeah, I got 25,434 feet squared for the smaller one. So we've got quite a range. Those 5 feet in radius make almost a 3,000 square foot difference in area. That's kind of crazy. And then Caitlin, do we have the last one yet? Oh, no, not quite. I was inverting some numbers in my head. Holy camole, Justin. 85,000 square feet of surface area on that big guy that they're going to build. So how much bigger is this big one's area than the one that I might have at my house? So we're going to take the big one, 85,000 486, and divide it by the small one, 2,826. And what do we get? I got 30.25. Anybody else get 30.25 when you did that division? Notice that we squared everything to find the area, right? So if we squared everything to find the area, in your calculator, do 5.5 squared. What is 5.5 squared? Does it equal 30.25? There's a relationship here that's really important, and it's hard to teach and hard to learn. If I square, like if I find the ratio of something that's linear, and then I square that linear thing to find the area, the ratio is also going to square. If these were three-dimensional things and we could find the volume of them, like say it was a box, if I change one length, right, if I double it, it's going to do 2 times 2 times 2. It's going to 8 times the volume, which is kind of a hard thing to think about. What is the arc length between the blades? So we talked about this for a hot second earlier in the week. Arc length talks about the piece of the circumference that's between those blades. So if we look back up at our picture, how many arcs are there? Are these divided into? How many blades do we divide these kind of circles into? We divide them into 3 sections, right? So for the last part, you're just going to take all your numbers. You're going to take your circumference divided by 3. Take your circumference divided by 3. Take your circumference divided by 3. Take your area and divide it by 3 to find the sector. So the arc length is the distance around the perimeter between the blades. We've cut that into thirds. And then the sector area, I think about pizza, right? I want 1/3 of the pizza. So Mikhail can have 1/3 of the pizza. So Jaquan can have 1/3 of the pizza, right? So we're going to take 188 and divide it by 3. And get our answer. We're going to take 235.5 and divide it by 3 and get our answer. Let's just take our smaller number, 565.2.
You said that you do what for section? About the area.
You're also going to divide it by 3 because each of those windmills are divided into 3 sections. So the arc length is talking about the outside, like where the blade, the end of the blade runs, and the sector area is this whole piece of pizza. And there's 3 sections. So a left, a right, and a bottom.
So what do you divide that by?
So you're going to divide the total area by 3 and the total circumference by 3. You're going to always, in this case, because there's 3 sections, you're going to always divide by 3. If you have a 4-bladed windmill, which they don't really make anymore, then you would divide it by 4.
Thank you.
Mm-hmm. So the math you're going to do is just on my screen right here.
For the area, I took out 5.5.
You got 5.5?
And the last one I got 42.1.
Nice. So the ratio between the arc length, because we didn't square anything, should be that 5.5. For the last one, you should get that 30.25 again. So let's double check all the math and see what we got. 44, 25, 26, 30. Check my numbers because, you know, a lot of times I put weird things in the calculator. My typing skills are not that great.
If you think you're typing it weird on the Desmos, you can just highlight the whole thing, Control C and Control V, and it's gonna be right.
That is 100% true. So the sector area, I did get a weird number. 2826 divided by 3, 942. Oh, because that's 854. 86 divided by 3. 85486 divided by 3 is 28495. And Mikhail, you said you got 10 for the ratio of the areas? Right? 28? What did I do wrong?
Oh, I'm putting that down.
Oh, because I divided by the total number. I'm tripping.
Yeah, I got 30.2.
942. There we go. I told you guys I do weird stuff. 30.2. Perfect. So the relationship between the areas is going to be squared, and the relationship between the linear measurements is going to be the same, equal. So for the arc length, it should be 5.5. And for the sector area, you should get 30.2 again. But note how much bigger, right? From 130 feet to 165 feet, that's a big difference. But in the area, 2,000 feet to 85,000 feet, or to be more fair, 3,000 feet to 85,000 feet, that's enormous, right? So a little tiny change, or even a significant change in a linear measurement, is going to be squared when you find the area. And it's going to be cubed when you find the volume. So really tiny changes can make a big impact when you go 2-dimensional and 3-dimensional instead of linear. And that was my whole goal for today. So if you would like, because I know a couple of you want to get that test out of the way, I'm going to go back into Schoology. So this is where we were. If you came in late and you were confused, what you needed to do was open up this document, open up your version of it, and we did day 1 and day 2. And I'll post a video of what we've just done so that you have that for a reference. I'll post that up here at the top. But what I do want you to do, because I'm giving you about 30 minutes right now, is if you would like to go start on that district test so you can get that out of the way, it is right here. And you can start that, and I think it's 45 questions. You're going to know some of it, and you're not going to know some of it. This is like a test for the traditional class, the traditional geometry class, and you guys were not a traditional geometry class. So if you get to something that you don't know, that's why I'm trying to give it to you early. Come tomorrow to class so we can ask questions about it. Okay? Other than that, I'm going to stop sharing my screen. I will post that video. We can hang out here if you want. And and yes, William, do you see Roblox open at the bottom of my screen? My third block was teaching me how to play. I am an abysmally bad Roblox player, but I'm going to practice and try to get it. I can try to figure out if I know how to do that. Yes, I can.
I'll teach you.
Okay. Let me post this video real fast. And